Hello everyone, welcome to the HSPF training by DSI. We are in the course HSPF500 in which we learn about the sediment erosion using HSPF. This is video HSPF510, how to simulate sediment erosion using HSPF. So for this exercise, what I did was that I used the same UCI file that we have been working on. It was named at Snake 430. I changed the name to Snake 510. That's it. Everything else is same. Now, there are two ways to simulate sediment in this UCI file. One way, which is harder, is to actually change the activity section and then add required tables, and you will have to refer to the user's manual to actually get the proper table names. Or you can use WinHSPF, which is very easy actually, because what it does is that it adds all the tables that you need automatically. So let's do this. So we open the UCI file here, and I go to functions, control cards, and there are two options. I'll go to descriptions. So what on this control card is that it gives you multiple options on what do you want to simulate, and depending upon whatever things that you want to simulate, you can check boxes on that. So we'll do sediment for a sediment simulation. On impervious land, it is called solids. On reaches, it's called Setran, inorganic sediment transport. When we change the Setran, the heat exchange also gets switched on, and because some algorithms can use water temperature, but we'll not use it here, so I'll uncheck that box. Click on OK, and then it says that since these control cards were changed, two new tables need to be added, and these are different parameters, set palm2 and set palm3, and it's saying should we add the table, say yes. And there are other for implant also tables need to be added, click on yes. And then in reach rest also there are tables need to be added, so we'll click yes, click save, and what we'll do is I'll just run it once just to make sure that everything has been set up right. Okay, so the model run completed. Looks like everything was set up right, and let's look at the UCI file. As you see, this sediment, this has been changed. Activity section for purlin. Now remember, it's still we will have separate parameters for purlin, separate parameters for implant, the way it was in hydrology. So that structure has not changed. One bad thing about WinHSPF is that it adds these kind of comment blocks multiple times, and it screws up the formatting. The UCI file is still valid, so if you want to keep on using WinHSPF for changing parameters, or you don't care about these formatting issues, then you can just simply ignore it and just move on. So and it does it on some specific tables. So for example, this pivot palm4 and mon interception, it has add all these lines. We can ignore that. Okay, so what it did was that it added these two parameters, set palm2 and set palm3. There's another table, set palm1, which sets up the algorithm for the sediment simulation, and whether we want to have the cover parameter monthly or not. But it has some default value, so you don't necessarily need to have it. So we'll talk about that once we get there. Similarly for implant, again solids have been switched on, and SLD Palm 2 is there, and there is no SLD Palm 1 because that's its algorithm, so we'll add those also. In reach res, HYFG is for hydraulics, this is for advection and sediment. So these things are same. General parameter, what is the width of the bed, warning. And so what we'll do is in the next video I'll go into the details of all of these parameters so that you can set up the basics. You'll definitely need to refer to the manual to get more detailed understanding for calibration, but I will help you get started in understanding some of these parameters. So these are the sediment parameters. It has set up the same parameter for all the reaches, which you almost always have to go and change. Another thing that specifically I want you to notice is mass link. So mass link, it might have been already there, but what it has set up is, we haven't talked about it before, is that this sets up distribution of sediment eroded from the surface into the reach res water body. Okay, so what it does. So first let's understand what is ISED. In the rivers, the sediment is divided into three parts: sand, silt and clay. ISED with this subscript of 1 means sand, ISED with this subscript of 2 means silt, and sand, silt, clay, and 3 is clay. And so what it is saying, that whatever sediment is eroded on the surface, once it goes from the surface to the river, then that sediment is divided into three fractions. In this case, it is 5% sand, 55% silt, and 40% clay. Depending upon your location, depending upon the soils data that you may have, you may use different fractions, but this is generally the default fraction it sets up. Similarly, from impervious land, there is similar distribution of sand, silt and clay in three different parts. In this mass link 3, where flow from one reach goes to another reach, everything is going from one reach to another reach, so it doesn't matter. But this makes this distribution. Now, as I said, you can change it. In some cases, you may have like BMP, so you may want to reduce the amount of sediment that is getting into the river, and we can talk about that later. So what we have done in this video is that we have very simply went on and checked the box so that HSPF could simulate sediment. Now the meteorological parameters, the meteorological boundary data, that was rainfall and evapotranspiration, that was needed for hydrology, that only that data is needed for sediment calibration or sediment simulation. So we don't need to add any more boundary data for that. So we didn't need to do too much preparation for that. Once we go to temperature and water quality, we'll need more meteorological data also. Anyway, so right now this UCI file has been set, and in the next video we'll go and we'll talk about some of these new parameters that have been added and how you can figure out better values of those parameters. So see you in the next video. Thank you for your time.